Okay, so the second part here, we're going to talk about simple harmonic motion. So if you go to page 390 on the bottom, there's on the left-hand side, there's a drawing there that I'm not going to draw. Okay, that is a piston. So as the thing goes back and forth, the piston goes back and forth. It's going to travel between negative A and A there. Okay. All right. And the harmonic motion is given as D. So the D at any given point is given as A times cosine omega. It's an omega, not a W there. Omega T. Omega meaning the angular velocity. Angular velocity. Go to top of page 391. There's a definition there. A point moving on a number line is in simple harmonic motion if its directed distance d from the origin is given by either this guy here or this guy here. Okay, cosine or sine, omega t, where a and omega are real numbers, omega is greater than 0. The motion has a frequency of, because the period is what? The period we always said was 2 pi over b, right? Which is omega here, right? In the sinusoid, remember we talked about that? Okay, so the period of this, which means that the frequency is 1 over the period, right? So we just flip this over and I get omega over 2 pi. Okay, which is the same thing they say there in the book. All right. So example number 5, let's say example number 5. In a mechanical linkage like the one shown in 4.97, the one that I did not draw, a wheel with an 8 centimeter radius turns with an angular velocity of 8 pi radians per second. A, what is the frequency? Okay, so the frequency is pretty simple, right? So this is example, is that 8, 5, 4, what is it? 5. And they want to know the frequency. So the frequency is right there, omega over 2 pi.
Students, please pardon interruptions. Have a quick announcement or a reminder. Please, students at lunch, please sit on the dots that are assigned. Please do that so we can keep our social distancing. And we need all the help we can with that at lunchtime. Also, some students missed the announcement about during spring break. Some of you guys might want to take advantage of that time to get your haircuts and make sure we're wearing appropriate attire to school when we return after spring break. Okay, thank you very much. Have a good lunch.
Okay, so he announced that in the middle, in the smack in the middle of my class period.
Yeah, I'm a bit lost right now. There must be someone coming to school for lunch.
Yeah. What the
Because study
heck?
hall students, people who mess.
I feel like at lunch would be the best time to say.
Whatever, okay. I'm not even gonna ask. So the omega was 8 pi over 2 pi, so it's gonna be 4. So your frequency is 4 cycles per second. In other words, in 1 second, you're gonna go from whatever point it is, 1 cycle, 2, 3, and 4. You're gonna have 4 separate cycles within a second, okay? That's what it means. Okay, what is the distance from the starting position? Exactly 3.5 seconds after starting. Okay, so if we use the cosine, we're gonna get what? We're gonna get, and what is the, if you look at the, what is the radius of that? The radius is 8, which means that the A is 8, right? So D is gonna be equal to 8 cosine 4t. Is basically where you are at, right? Because my frequency, no, my frequency was not, never mind. This was 8 pi t, right? 8 pi t, 8 pi t.
That's the arc point?
8 pi, what?
That's the arc point?
No.
Like trying to figure.
This is the angular velocity, is that what you're asking? Angular velocity?
Yeah. I guess.
Right, the omega was 8 pi, right? Omega was 8 pi, right?
Because I figure model.
Yeah. So we call this 3 point, so this, you want to know when this is 3.45, right? 3.45, that's what you're trying to solve. So you would divide it by 8. you would do that. 8 pi t is going to be equal to arc cosine 3.45 over 8. Right? And what do you get if you do that? Oh, wait a minute. Oh, they gave you the time, right? They gave you the time. What am I doing here?
I don't know.
It was that announcement.
It's that stupid announcement that, okay, so 8 cosine 8 pi times 3.45. Right, just run it through, right? If you run it through, you get 2.47. Okay. Example number 6. Example number 6 is a little kind of iffy there. I think the book is incorrect on this one, but let's go see what happens here. Example number 6. Example number 6. A man had a mass oscillating up and down on the bottom of a spring, assuming blah, 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 blah. It can be modeled as harmonic motion. If the weight is displaced a maximum of 5 centimeters, find the modeling equation if it takes 2 seconds to complete one cycle. Okay. 2 seconds to complete one cycle, right? Okay, so what is that? That's the period, right? The period is 2 is what it's saying, right? And the period was 2, which is 2 pi over b, correct? Right, remember that, 2 pi over b, right? So b is going to be equal to pi, right? So it's going to be sine pi t something or another, right? Okay, now all I need is the amplitude. The amplitude is what? I go from, I have a thing here, right? And does it say I push it in or not, or does it say where it starts? Does it? Doesn't really say. Okay, so if we assume that it starts from 0, okay, it would be a sine, right? And if it goes up first and then down, up and down, up and down. So in a real life, what's going to happen? If I push it in and I let go, or if I pull it down and let go, what's going to happen? It's going to do this, it's going to do this, but it's going to stop in the middle, right? But they're saying in an ideal world where there is no air resistance or anything like that, it will just go on there forever, right? Okay. So if we start from 0 and it goes up like this, what kind of curve is this? This is a sine curve, right? Sine. Okay. Well, all I need to know is how high and how low it goes. I think that was 5, correct? 5? Yeah. Was it 5? Yeah. Okay, so what are we trying to find out? The modeling equation. So there it is right here. This is the modeling equation. Okay. Now, if I told you that I pulled it down 5 and I let go at time 0, what happened? What's happening then? Then what's happening is that you are actually starting from the minus point, right? And you're going to go up like this, right? So this would be what? This would be a negative cosine pi t. Do you understand why it's a negative cosine? Because it starts from the bottom here. If it was a regular cosine, it would start from here, right? But since I'm starting from here and going down that way, it's a negative cosine. If I told you I pushed it in and let go, then it would start from here and it would go down like this, right? So that would be just a regular 5 cosine pi t at that point. Okay, can you see how this question could be asked several different ways? Right? Okay, depending on where the starting point is at 0, right? All right, we're good. We're done.